Hello, my dear students. I welcome you all to this session. So here we are going to discuss about the AIET 2 NEET solutions of chemistry class 11. Okay. So here I have selected some questions which are very important from this exam and the questions which you feel it very difficult. Okay. So let's do one by one. The first question for today's session is question number 51 of your question paper. So it says that which has maximum number of atoms. So we have 4 options. Okay. So we are asked to find out the maximum number of atoms. So we know that to find out the maximum number of atoms, we have to use the mass and molar mass concepts. Okay. So the number of atoms can be calculated using the formula the given mass divided by the molar mass into the Avogadro number, which is represented by Na. Okay. So now let's go for each option. Let me go for option A first. So here we have 24 gram of carbon whose atomic mass is 12. So the number of atoms for carbon is equal to number of atoms of carbon is equal to the given mass is 24 gram and the molar mass of carbon, which is nothing but the atomic mass here is 12 into Avogadro number. So if we cancel this, we will get 2 into Avogadro number as the answer. So in the same way, if we are doing it for the option B, the number of atoms for option B, which is for iron, is equal to the given mass is 56 and the atomic mass is also 56 into Avogadro number. So it will be equal to 1 Avogadro number, which is Na. And then coming to option C, we have to calculate for aluminium. The given mass is 27 and the molar mass is also 27. So again, we'll get 1 into the Avogadro number. In option D, we have to calculate for silver. So the given mass of silver is also 108 and the molar mass of silver is also 108. Into the Avogadro number will give 1 into Avogadro number. So among these 4 options, if you see, the one which is having the maximum number of atoms is option A, because there we have the number 2 multiplied with the Avogadro number, and the remaining options we have only the Avogadro number. Okay, so option A is the correct answer for this question. Got it? So I hope you understood this question. Now let me move on to the next question, which is question number 55. So we have 2 lists, list 1 and 2, and we have to match it. Okay. So we are provided with N, L, M respectively, which are nothing but the principal quantum number, azimuthal quantum number, and the magnetic quantum number. So let's go one by one. So in the list 1, in A, we have number of value of L for an energy level N. So the number of value of L for an energy level N is what? Suppose if I am having the energy level as 1, okay, if the N value is equal to 1, L can have values from 0 to N minus 1. Okay, so if the value of N is 1, then L can have values from 0 to N minus 1. Okay, so it is from 0 to 1 minus 1, which is actually 0. So we are ending up with only one value, which is 0. Okay, we are ending up with one value, which is actually 0, and which is nothing but the value of N. If the value of N is 2, 0 to 2 minus 1. 0 to 2 minus 1. So we have 0 and we have 1. So we are ending up with 2 values. Okay, if the N value is 3, 0 to 3 minus 1. So 0, 1 and 2. So we are ending up with 3 values, which is nothing but the value of n. So the number of value of L for an energy level is nothing but the value of n itself. So A goes to yes. Okay. Next, coming to B. The values of L for a particular type of orbit is. Orbit is nothing but the principal quantum number. So for a given orbit, given value of an orbit, the value of L can vary from 0 to n minus 1. So it is given in P. So B goes to P. Then coming to C. The number of value of M for L is equal to 2 is. So for a given value of L, M can have values from minus L to plus L. Okay. So here the value of L is given as 2. So if L is equal to 2, the value of M will be minus 2 to plus 2. So it is minus 2, minus 1, 0, plus 1 and plus 2. So totally we have 5 values. Okay. So C goes to R. And the last one, the values of M for a particular type of orbital is equal to minus L to plus L through 0. Okay. And the value of M is from minus L to plus L. So here we have seen that formula. So D has to go to Q. So this correct match is given in option D. So option D is the correct answer for this question. Okay. Now coming to the next question. Question number 59. An amount of 2 moles of KClO3 is decomposed completely to produce O2 gas. How many moles of butene, which is C4H8, can be burnt completely by the oxygen gas produced from the decomposition reaction? So what they are trying to say, 2 moles of KClO3 is getting decomposed. Decomposition means one molecule will be broken down into two or more than two. Okay, so it decomposes to give 2 KCl and it produces 3 moles of oxygen. Okay, now C4H8, which is actually the butene molecule, is burnt with oxygen gas. Is burnt with the oxygen gas produced from this reaction. Okay. So now we have to find out the number of moles of C4H8 burnt completely by the oxygen gas produced, which is actually 3 moles of oxygen gas produced from this reaction. So basically, if you see to the complete reaction of this decomposition of 1 mole of butene, so 1 mole of butene takes 6 moles of oxygen to produce 4 moles of carbon dioxide and 4 moles of water. So for complete combustion, the products CO2 and H2O has to be produced. So for the complete combustion of 1 mole of butene, 6 moles of oxygen is required. But we have only 3 moles of oxygen produced from this decomposition of KClO3. Okay. So the 3 moles of oxygen might have reacted with half a mole of this butene. So 1 mole of butene is taking 6 mole of oxygen. So we have only 3 mole of oxygen in our hand now. Means half of this, right? Half of this. So half of the mole of butene would have got reacted. Means 0.5 moles of butene would have got reacted and with the oxygen to produce the carbon dioxide and water. So the number of moles of butene that got reacted with oxygen gas, 3 moles of oxygen gas is 0.5. Okay. So which is actually option A. Option A is the correct answer for this question. Okay. Now moving on to question number 63. If the ionization energy of hydrogen atom is 21.79 into 10 to the power 19 joules, then the magnitude of energy of second excited state of lithium 2 plus ion is. So we are provided with the ionization energy of hydrogen atom, and we have to find out the magnitude of energy of second excited state of lithium 2 plus ion. So first of all, let me take the energy, the calculation of energy for any nth orbit, and it is calculated using minus z square by n square into 13.6 electron volts. So this is how we have to calculate the energy for any type of ion. Okay. Now for lithium 2 plus ion. So we are asked to find out for lithium 2 plus ion, right? So for lithium 2 plus ion, what is the value of Z? Z is the atomic number. The atomic number of lithium is 3. Okay. And the value of N. So N will be what? So here it is given that the state is second excited state. So this is the ground state. The value of N is 1 here. And this is the second is equal to 2 state, and this is the third state. So for lithium 2 plus, the configuration is 1s1. Because the configuration of lithium is 1s2, 2s1. So 2 electrons are lost. So 1 electron from 2s and the another electron from 1s would have got lost. So the remaining one will be there here in the 1s orbital. So this is that electron. Okay. And if this electron has to enter into the n is equal to 2 state, then we call that as the first excited state. First excited state. And if it goes to n is equal to 3, then we call it as second excited state. Okay. So now we have to find out the magnitude of energy of the second excited state of lithium 2 plus. Okay, so n value will be equal to 3. Now substitute the value of Z and N here in this equation. So we will get E3 is equal to minus 3 square divided by 3 square into 13.6 electron volt. So they get cancelled with each other. So we are ending up with minus 13.6 electron volt. But in all the options, if you see, answer is given in terms of joules. What we have to do? We have to convert this electron volt to joule. So for the conversion is 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. Okay, minus 1.6 into 10 to the power minus 19 joule. So therefore, E3 is equal to, just multiply minus 13.6 into this 1.6. So we will end up with 21.79 into 10 to the power minus 19 joule. So it's option A is the correct answer for this question. Okay. So just we have to take this formula and apply the given terms and the required. Got it? Now moving on to question number 64. What will be the de Broglie wavelength of an electron moving with the velocity of 1.2 into 10 to the power 5 meter per second? So we have to find out the de Broglie wavelength, which is lambda. Okay. And the velocity of that electron is given. B value is given in terms of meter per second. So the relationship between lambda and B is lambda is equal to h by mb. Okay, where h is the Planck's constant and m is the mass of the electron, b is the velocity of electron. So we know that the value for Planck's constant is 6.626 into 10 to the power minus 34 joule second. The whole divided by the mass of the electron is 9.1 into 10 to the power minus 31. So these two are the constant terms which we already know, right? Now substitute the value of B. So it is 1.2 into 10 to the power 5. So the lambda is equal to 6.068 into 10 to the power minus 9 meter. Okay. So option A is the correct answer for this question. Clear? This is a direct substitution using this lambda is equal to h by mv for that. All right. Now coming to question number 67. An X-ray tube is operated at 50,000 volts. The shortest wavelength limit of the X-rays produced is. An X-ray tube is operated at 50,000 volt. Mean that is the energy value. Okay. So energy is 50,000 volt. So to convert, we need to convert this volt to joules first. So the conversion will be from electron volt to joule. We have to multiply by the number 1.6 into 10 to the power minus 19. So 50,000 into 1.6 into 10 to the power minus 19 joules will give 8 into 10 to the power minus 15. Okay. So this is the energy value. And we are asked to find out the lambda value. Okay. So we know that lambda is equal to hc by E. So from where do we get this relation? We know that E is equal to hc by lambda, right? So from this only I have got this lambda is equal to hc by E relation. So here h is the Planck's constant again, 6.626 into 10 to the power minus 34, and c is the speed of light, which is 3 into 10 to the power 8, the whole divided by the energy is 8 into 10 to the power minus 50. Okay. So which is equal to 2.485 into 10 to the power minus 11 meter, which is actually equal to 0.2485 angstrom. Okay. So option C is the correct answer for this question. All right. We are asked to find out the wavelength, shortest wavelength limit of the X-ray produced. The wavelength is coming out to be option C for this question. Clear? Just you have to concentrate on the conversions, the unit conversions. So that is very important to get the correct answer. Okay. Now coming to the question number 68. Calculate the energy of a quantum of radiation of wavelength 250 nanometer. So the wavelength is given, lambda is given, and we have to find out the energy of a quantum of radiation. So just now we have calculated that E is equal to hc by lambda, where h is 6.626 into 10 to the power minus 34 into the speed of light is 3 into 10 to the power 8 meter per second. Lambda is also given to us in the question. This 250 nanometer. We have to convert this nanometer to meter. Okay. So the conversion is 10 to the power minus 9 meter. So if I calculate this, I will get the E value as 7.95 into 10 to the power minus 19 joule. Okay. Clear? So option A is the correct answer for this question. Now coming to question number 71. When an electron makes a transition from L shell to M shell, what happens? So L shell is the lowest energy containing shell. This is shell L. And M will be higher than L. So K will be lower than L. K, L, M, N, like this it goes on, right? So if an electron is present in L shell and if it tries to go into the M shell, what happens? So this is the lower energy state, and if it has to go from lower energy state to higher energy state, it has to observe some energy. It has to observe the energy which is required to go into the M shell. Okay, so this much of energy is required for this electron to enter into the M shell. So in that case, energy is observed for this electron for this transition to take place. Okay, energy is observed. So option B is the correct answer for this question. Okay. Now coming to the next question. Which of the following sets of quantum numbers is correct for an electron in 4f orbital? So for 4f orbital, if I talk about for 4f orbital, so what is the value of n? So value of n is 4. So n is equal to 4. If n is equal to 4, L value can be from 0 to n minus 1, right? So 0 to n minus 1, 0 to 4 minus 1. So it is 0 and 1, 2, 3. 4 minus 1 is 3. So these are the values of L. Okay. And M can have values from minus L to plus L. Okay. For 0, minus 0 to plus 0. For 1, minus 1 to plus 1. For 2, minus 2 to plus 2. For 3, it is minus 3 to plus 3. Okay. Minus 3 to plus 3. So these are the values of M. And coming to S, S can be either plus half or it can be minus half. So this is all about the quantum numbers. Okay, set of quantum number for 4f orbital. Now we'll check one by one. So let me go for option A first. So here n is given as 4. Yeah, that is correct. And L is given as 3. Yeah, L is equal to 3 is one among the answer. And M is plus 1. Yeah, plus 1 is also present in L is equal to 3. And S is equal to plus half. Yeah. So option A is coming out to be the correct answer for this question. So that would be the correct answer. And we can check with other options also. In option B, it is given that n is equal to 4 and L is also equal to 4. No, for n is equal to 4, L cannot be equal to 4. We don't have 4 in the L column, right? So that cannot be the correct set. And for option C, for n is equal to 4 and L is equal to 3, M is equal to plus 4. No. So L is not equal to 4. So then how come M can be plus 4? So because of this, option C is also going as the incorrect answer. Next, coming to D. We have n is equal to 3. No. For 4f orbital, n is equal to 4. It is not 3. So here itself, this option is going incorrect. So option A is the correct answer for this question. Okay. Now coming to question number 77. The maximum kinetic energy of photoelectrons ejected from a metal when it is irradiated with radiation of frequency 2 into 10 to the power 14 is 6.63 into 10 to the power minus 20 joule. The threshold frequency of the metal is. So we are asked to find out the threshold frequency, which is actually mu naught. Mu naught we have to calculate. Okay. And we are provided with the frequency value. Frequency is 2 into 10 to the power 14. The new value is given. And also the maximum kinetic energy of the photoelectron is also given as 6.63 into 10 to the power minus 20. So kinetic energy is also given. So we know that kinetic energy is equal to half mv square. We know that kinetic energy is equal to half mv square and it is equal to h into mu minus mu naught, right? And that value is given, kinetic energy value is given as 6.63 into 10 to the power minus 20 joules, which is equal to, so in terms of kilogram meter square per second square, so it is equal to 1 kilogram meter square per second square. And h is also a Planck's constant, 6.626 into 10 to the power minus 34 kilogram meter square per second. And the new value is 2 into 10 to the power 14 minus mu naught. Okay. So here 6.626 can be approximated to 6.63 and we can cancel it. Okay. And here 10 to the power minus 20 will go away and remaining 10 to the power minus 14 will be there. So we have 1 into 10 to the power minus 14 minus 2 into 10 to the power minus 14, which is actually equal to minus mu naught. So 1 minus 2 is, sorry, it is not minus 14, it is plus 14. So if it comes to the other side, it becomes plus now. So plus 14. So 1 minus 2 is minus 1 into 10 to the power 14, which is equal to minus mu naught. So minus minus gets cancelled. So mu naught is equal to 1 into 10 to the power 14 per second. Okay. So the threshold frequency is equal to 1 into 10 to the power 14 per second. So option D is the correct answer for this question. Okay. Now moving on to question number 87. For an element, various successive ionization enthalpies in kilojoule per mole are given below. The element is. So if you observe the ionization energy value, so what is basically the ionization energy? The energy required to remove the outermost electron, okay, or the valential electron in an isolated gaseous atom is called as ionization enthalpy. Okay. So for an atom, the first ionization enthalpy is around 500 and second is around 1000, third is around 2000, fourth is around 11,000. So till the third ionization enthalpy, the values are getting doubled from 500 to 1000 and from 1000 to 2000 kind of. But when we go from third to fourth ionization enthalpy, the jump is very high. So suddenly it is going from 2000 to 11,000. Okay. So third ionization energy is low, but the fourth ionization energy is very high. So what does this mean? This means the presence of 3 valence electron in the corresponding atom. So this shows the presence of 3 valence electrons in the atom. Valence electrons in the atom, which we have to find out. Okay. Now we have to find out the element which has 3 valence electrons. So if I go for option A, silicon, it has 4 valence electrons. Right? 4 valence electrons. If I come to phosphorus, it has phosphorus has 5 valence electrons and aluminium has 3 valence electrons and magnesium has 2 valence electrons. Okay. So the answer is option C. So aluminium atomic number is 13. Electronic configuration is 1s2, 2s2, 2p6. 1s2, 2s2, 2p6, 3s2 and 3p1. So third shell is the valence shell and it has 3 electrons in it. Okay. And for the shell distribution, it will be 2, 8, 3. So there are 3 valence electrons present for aluminium. So after the removal of these 3 electrons, if we have to remove the 4th electron of aluminium, then I have to enter into the second shell and it is completely filled. So the removal of 4th electron becomes difficult for aluminium, and that's why the ionization energy of the 4th ionization energy of aluminium is very, very high. Okay, because we have to remove from the inner shell. So the inner shell electrons are more closer towards the nucleus. So more amount of energy is required to remove it. Got it? So from the valence electrons values, we can find out the answer for this question. All right. Now coming to question number 88. Which one of the following sets of ions represents a collection of isoelectronic species. So what is meant by isoelectronic species? Iso means same. Electronic means number of electrons. The species which has same number of electrons are said to be isoelectronic in nature. Okay. Now, I have 4 sets. In these 4 sets, I have four species. So, let me go from option A, potassium. So, the atomic number of potassium is 19. Okay. And if it loses one of its electron, it becomes a K plus. So, now the total number of electron is 18. Okay. And next coming to Cl minus. The atomic number of chlorine is 17. And if it gains one electron, it is becoming an anion. 17 plus 1 is 18. Then coming to magnesium 2 plus, the atomic number of magnesium is just a second. Yeah, sorry for the interruption. The atomic number of magnesium is 12. Okay. So now it loses 2 of its electrons. So 12 minus 2 is 10. It is a 10 electron species now. Now coming to scandium. The atomic number of scandium is 21. And if it loses 3 electrons, it is having 18 electron in its species. Okay. So because of this magnesium 2 plus, option A is going incorrect. Okay. Even though the other species have 18 electrons, because of magnesium 2 plus, option A is not the correct set of isoelectronic species. Then moving forward with option B. So it has sodium. The atomic number of sodium is 11. Okay. So 11 minus 1 because it loses one of its electrons. So 11 minus 1 is 10. So it is a 10 electron species. And then coming to calcium, atomic number of calcium is 20. 20 minus 2 is 18. So here itself it is going wrong. So option B is also incorrect. Then coming to option C. So potassium 18 electron, calcium 2 plus 18 electron, scandium 3 plus 18 electron and Cl minus also 18 electron. So option C is a set in which all the 4 species has 18 electrons in it. So option C is the correct answer for this question. Okay, it is a collection of isoelectronic species. And coming to D, sodium has 10 electron. Magnesium 2 plus also has 10 electron. Aluminium 3 plus also has 10 electron because aluminium atomic number is 13 and 13 minus 3 is 10. Okay, so it is also a 10 electron species. But chlorine, if you see, it is an 18 electron species. So because of chlorine, option D is going incorrect. Okay. Option C is the correct answer for this question. Now coming to question number 89. The correct order of electronegativities of nitrogen, oxygen, fluorine and phosphorus is. So nitrogen, oxygen and fluorine belongs to the second period and phosphorus belongs to the third period of the periodic table. So let me write the period number and also the group number. So the group number of nitrogen is 15 and 16, 17. So nitrogen belongs to the 15th group and second period. Oxygen belongs to the 16th group and second period. Fluorine belongs to the 17th group and second period. Phosphorus belongs to 15th group and third period. So this is the placement of each atom in the periodic table. Now, what is the trend for electronegativities of these atoms? Across the period from left to right, electronegativity increases. Electronegativity increases. And on moving down the group from top to bottom, electronegativity decreases. Okay. So which is the most electronegative element here? Fluorine. Fluorine is the most electronegative element and it is given in option A, B and D. So next, the second most electronegative element is oxygen. So oxygen is also given in the second place in option A and B. Next, on moving down the group, it decreases, right? So if I compare for nitrogen and phosphorus, nitrogen will have the highest value because it decreases. So phosphorus will be least electronegative in nature. So first fluorine, oxygen, nitrogen, and then only phosphorus. So option B is the correct answer for this question. Okay. Fluorine is the most electronegative and phosphorus is the least electronegative. Next, coming to question number 97. The maximum number of electrons present in an orbit L is equal to 3 is. So L is equal to 3 means it denotes the F orbital. L is equal to 3 means it denotes the F orbital. Okay. So for L is equal to 3, the orbital is F. The orbital is F. And F orbital. For F orbital, the values of N can be from minus L to plus L. Means from minus 3 to plus 3. So minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. So totally we have 7 orbitals. Okay. So 1, 2, 3, 4, 5, 6 and 7. So we have 7 orbitals for this L is equal to 3. Okay. 7 orbitals and each orbital can take 2 electrons. So 7 into 2 will be 14 electrons. Okay. So the maximum number of electrons present in an orbit L is equal to 3 is 14. So option D is the correct answer for this question. Okay. Now coming to question number 98. The Heisenberg uncertainty principle is not valid for. So coming to the principle, so what is Heisenberg's uncertainty principle? So it says that it is impossible to measure simultaneously both the position and the momentum of a microscopic particle with absolute accuracy or certainty. Okay, it is impossible to measure simultaneously. So at the same time, you cannot measure the position and the velocity or the momentum. Okay, momentum is nothing but mass into velocity. So I can say momentum or velocity. It is impossible to measure both the momentum and the position of a microscopic particle with absolute accuracy and certainty. This is Heisenberg's uncertainty principle. So it is actually valid only for microscopic particle, not for macroscopic particle. Okay, it is applicable for microscopic particles like electron, proton. Okay, so which are moving with very high speed. Which are moving with very high speed. Means the mass should be very less. Moving with a very high speed. So here if you look into the options having this concept in your mind, option A has moving electron. Yeah, electron is a microscopic particle. So it is applicable for electron. And option B has motor car. It is a macroscopic object, and C is a stationary particle. Stationary means it is not in movement, it is not moving, so it is not applicable for it. So it is not applicable for a stationary particle which are not in motion, and also for the macroscopic object which is a car. So it is not applicable for, it is not valid for both option B and C. Means option D is the correct answer for this question. Okay. I hope this question is clear. So now I'll go for the last question of this session, question number 100. And it says, which of the following has least de Broglie wavelength? So how to find out the least de Broglie wavelength? So here we are provided with electron, proton, carbon dioxide and sulfur dioxide. So we can find out the least de Broglie wavelength containing the particle using the mass. Okay. We know that lambda is equal to h by mv. So what is the relation? The wavelength lambda is inversely proportional to the mass, keeping the velocity constant for all. Okay. So mass is inversely proportional to wavelength. So the one which is having the highest mass value will have the least wavelength. Okay. So now let's find out. In option A, we have electron. So the mass of electron is equal to 9.1 into 10 to the power minus 31 kilogram. Okay. Then coming to option B, we have proton. The mass of proton is 1.67 into 10 to the power minus 27 kilogram. Okay. Then coming to the carbon dioxide, the mass, the molar mass is actually 44 gram, which is equal to 0.044 kilogram. Then coming to option D, we have sulfur dioxide, whose mass is 64 gram. It is equal to 0.064 kilogram. Okay. So if you compare all the four values here, the one which is having the highest mass value is sulfur dioxide. Okay. So that molecule, sulfur dioxide molecules, wavelength will be very, very less compared to the other. Okay. So option D is the correct answer for this question, which has a very least de Broglie wavelength. Okay. Now, I hope we are done with this. And I hope you guys have understood the concepts. And I hope this session is very useful for all of you who are watching this. And thank you so much for listening the lecture, listening this session. To meet you all with a new set of questions in the next session. Okay. Till then, take care. Thank you so much, all.